which is used for CI/CD deployment. So Gitops it uses Git as a single source of truth for infrastructure and deployment. So these are Gitops. What it does is it helps in managing and deploying our software, also using Git. So that's what it does. So to me, I think GitOps is more better whenever one wants to manage or deploy his or her software. So GitHub is one of the best tools. So I would like you to listen. Maybe at the end of this class, I'm still going to ask if GitHub is more preferable. So just listen while I go through my slide. So now the next thing is, what is GitOps? GitOps is an operational framework that takes DevOps best practices. So now, what this GitOps does is it uses Git to manage and deploy our infrastructure using Git as a single source of truth. So that means our system, our code are being stored in our GitHub, and this GitOps uses our code stored in Git as a single source of truth to deploy our apps on our server. So now this GitOps tools, it has three main pillars. So now before you can be able to, you need to understand these three pillars of GitOps tools. So GitOps tools has the declarative part, it has the version part, and also have the automated part. So now let me start by the declarative part. Hope you can all hear me.
Don't go foul.
Hope you can all hear me.
We can hear you.
So this declarative part, before you can make use of GitOps in your CI/CD pipeline, you need to write a script. And this script is known as a declarative script. So this script, what it does is it describes the state of our system, not like the usual CI/CD pipeline whereby you write your stages like install. After installing, you start the server. After start, you run. So in this GitOps, you don't do that. What you just do is just write a declarative state, just declaring the state of your system. And after that, you now move to your Git. That's where you are going to store so the entire system state is stored in Git. So you store your code and everything on Git. And one, it is being saved, it is being versioned on your Git. The next thing is this GitOps, it has an operator. What this operator does is it always tracks your code whenever you make changes and when you make the changes. So it has this function whereby anything you do on your code, it take record of it. That's an operator that take record of it, whether the time you made the changes and what the changes you made. So after that, the next pillar is the automated part. So after you've been, maybe you make a change or after you finish storing your code in GitHub, the next thing is once you click on commit, this GitHub tool, what it does, instead of, the normal CI/CD tool, after you maybe save your code on GitHub, the next thing is to start configuring it so you can run the pipeline on maybe the software. Let's say Jenkins, for example. Maybe you're using Jenkins, for so you have to go to Jenkins to go and run the pipeline. But in this case, it's different. Once you change your code or you do any changes on your code and you click on commit, immediately you just commit that code. This GitHub tool is going to take it automatically and automatically run your deployment on your server without manually going to run the pipeline. So now, the next thing is the core principles of GitOps. So GitOps has core principle, which I said earlier. The first thing is you have to write a declarative configuration file. And this configuration file is written in either YAML or JSON format. And what it does is it just describes the state of your system. So now the next thing is the continuous reconciliation. So now in this continuous reconciliation, what it does, what the operators do here is, let's say, for example, you have a cluster, as in you have a deployment that is running, you have a software that is running, and in your code, you wrote that in your Kubernetes code, you wrote that three cluster must be running on the software. And let's say someone now come around to make changes, and let's say mistakenly put one cluster. So once you can see that there's a difference, 3 and 1. So now what this GitOps tool does is that it's going to check what you have on your server and what the changes you made. If they are similar, it's going to carry on with the automation. But if it's not, I notice that these changes that three was there and you are changing it to one, and you see that it doesn't relate. So what it does is it just automatically stay at that three. It doesn't maybe because you wrote three fine. No, it doesn't do that. So it automatically stay at that three to ensure that your cluster, your software is correct. So that's what this continuous reconciliation does. And it also have this auto audit trail. What this audit trail does is that, let's say for example now you want to make a changes in, I know what whenever you have your software running and you want to make anything, you have to create a separate branch. So on that branch you make your necessary changes. So after doing those changes on that branch and you want to merge it to the main branch, normally let's say your your Git is going to ask for permission for merging if you want to merge, because so your Git is going to ask for permission before it carries on with that merging. So once you make your changes in the branch and you want to merge it together, it's asks for this permission for the pull request. So once this pull request is being approved, and whenever you want to, so the team lead, let's say the senior DevOps engineer is the one in charge of that. So before you can be able to match that, the senior DevOps engineer must be aware. So after going through the code you wrote and he saw that maybe he sees that the code is correct, so he's going to approve it. And the way he's going to approve it is by merging it. So once this the senior DevOps merge the code together, then the automated delivery is going to take. But before that, I know I told you that this Gitops, it has an operator that take track. So those changes that you made, and when you made this operator is going to keep track of it. It's going to keep track of it. So whenever you want to check on the changes you made, what you did that is causing some kind of error or something like that. So it keeps track of the changes you made. So after this audit trail, then it moves to the automated delivery. So after the approval has been made, or maybe you made a change and you just commit the changes, this GitOps tool, what it's going to do is going to trigger an automatic deployment without you manually going to the CI/CD tools you are using. Let's say, for example, I was using Jenkins, so without you going there, it just automatically pick up these changes and run your deployment on your server immediately. So now, how does GitOps work? So the way GitOps works is, number one, the first thing, the developer is going to write the code. After writing the code, he's going to push it. After pushing this code, the PR review I was talking about is like the senior engineer is going to be aware, the senior DevOps engineer is going to be aware of whatever changes you are doing. So after the developer pushes, it's going to ask for pull request. So after the senior developer approves the pull request and merge it together, so this GitHub operator, it detects the changes and it automatically do that continuous reconciliation I told you about to check if the changes you made is similar to what you have on the server. So if there's any difference, it's not good. But once it notices that the changes is similar to what is on the server, is automatically carry on with the deployment without you manually doing that process. So that's how GitOps works. So now the normal way, GitOps versus the traditional CI/CD. So now in traditional CI/CD, once the deployment trigger, once the developer deployment trigger, the pipeline pushes. Then in the GitOps tools, just a git command is going to trigger the automated deployment to your server. But in the traditional way, once you after making your changes or anything, you have to go to the tools you are using, maybe Jenkins, to go and rerun the pipeline before the changes can be identified. So the next one is state management. In the normal, I don't want to mention something, but because there are a lot of CI/CD tools. The imperative script, you have to write your imperative script, whereby you write the stages. Maybe you're going to deploy. After deploy, you create an image. After you can install Docker. You can just you're just going to write how you want your CI pipeline flow to be. But in GitOps, you just write a declarative configuration file stating the state of the system. So that's all you just need to do about the GitOps. Then next one is a drift detection. In the traditional way, once you make any changes, and if after you make changes and you go to let's say after you make any changes, if there's any error okay, after you make any changes, sorry, you have to go to your normal the tool you are using. Let's say Jenkins. Let me use Jenkins for example. So you have to go to Jenkins to go and run your pipeline. But for this GitOps, it happens automatically. So once there's a changes, once you make any changes, after making the changes, you have to go to your Jenkins to go and run the pipeline. But for GitOps, once you make any changes, immediately you just click on the commit command or the merge request has been approved. It automatically deploy the software without you manually going to the. So this in terms of audit trail, the traditional CI/CD, if you want to detect any errors or changes made, or you have to go check the CI/CD logs. You have to check the CI logs before you can be able to do that. But in GitOps already has this operator that handles this. So whatever changes or anything, I'm coming, sorry. So whatever changes you make, please, can you still see my screen?
Yes, we can.
Okay. Sorry. Okay. So as I was saying, so for the audit trail, your Jenkins, if you want to check the logs, you have to go to the Jenkins and start checking for the log. But in GitOps, all this has been tracked on your Git. So once you go to you'll see the history of the changes made and when the changes was made. So an advantage of the GitOps tool. The other one is the rollback, whereby you go to the this into, let's say you made the changes in your pipeline and you rerun your pipeline and you start getting error. In the traditional way, what you need to do is you need to start rewriting the script or anything. But in GitOps, once you make any changes like that and it automatically run, and you see that the result you are getting is not what you want to get, you just click on Git revert. It's just a button. Once you just click on Git revert, then it's going to reverse back to the normal way it was, instead of going to start correcting one or two things on your pipeline. So just this Git revert is going to revert your distance back to its normal, your software back to the normal way it was. Then access to cluster. In your normal CI/CD, before you can have access to run your pipeline, maybe to connect your GitHub to the Jenkins, you have to start writing the credentials, tokens, and stuff like that. But for GitOps, you don't need to go through all those processes. What you just need to do is you just your GitHub link, you just attach it to the GitOps tools, and it's going to pick it automatically from there. So it doesn't need any credential criteria or anything before you can be able to deploy your app. So you just need the your Git link, and it automatically handles the deployment. So now, examples of GitOps tools. We have the Argo CD, which is most popular. This is the one I'm familiar with. We also have the Flux CD, which is used for CNCF projects. We also have the Rancher Fleet. This one is used for multi-cluster, and we also have the WIF GitHub, which is enterprise. But the one that is commonly used and is mostly used is the Argo CD. So now, the key benefits of GitOps, like I said earlier, in terms of security, you don't need to go through all these credentials. You don't have to start writing credentials and saving credentials before you can be able to deploy. In terms of one benefit of it is that in GitOps, you don't need to go through all those processes. Just the GitHub link, and it automatically do the process for you. That's one advantage of GitOps. The other thing is fast recovery. Like I said earlier, let's say in your CI/CD pipeline, you made some changes, and after rerunning the pipeline, you discover that you start getting some errors. In the normal Jenkins, for example, as I was saying, you have to start going to identify the lines that you start having errors and you start making some correction. But in GitOps, it is not like that. You just have a button you are going to click. There's something you are going to press, which is called Git revert. And once you click on that Git revert, it automatically reverts your pipeline to the normal way it was. And we also have consistencies. So now, this GitOps, it has this feature, this whereby once it notices any changes, once you make any changes or anything, and any changes, and you click on commit, it always ensure that the pipeline runs automatically, and it ensures that the changes you made is similar to what you have on your cluster that is running already. So it ensures that, so if there's anything, so it ensures that your environment are always sync with Git. It ensures that there's no issue, there's no problem. So that's one of the function of the Gitops. And it also have this reliability, automated reconciliation. So it ensures that your cluster is in its desired state. And I told you, for example, without manual intervention, I told you earlier that, let's say, for example, your cluster, 3 clusters are supposed to be running, and someone now mistakenly come and put 1 cluster. So it ensures that the previous state of your software, it maintains that. So any changes you want to do to be similar to what you have already in your cluster. So there shouldn't be much changes like that. It should just be similar to that. So that's one of the feature of GitHub. And another thing is developer experience. So this GitHub is, will I say, is developer friendly. You don't need to learn more. There's no additional tool you need to know to achieve this process. It's just the normal deployments developers does. So that's the normal process. So there's no new thing to learn. And that thing is compliance. It has this audit tree whereby the changes you make, it keeps track record of when the changes was made and what changes was made. So these are the benefits of the GitHub tools. So now, I now summarize and say that GitHub is not just for code. With GitHub, your infrastructure, deployments, and configuration all live in Git, giving you speed, safety, and confidence. So if it is not Git, it does not exist. So I think I've come to the end of my teaching. So is anyone having a question for me, please?
All right, thank you very much, Abdulraheem. Thank you so much for that insight, for one. Because of our time, we might not be able to take questions. Some of us need to join and stand up right away. Thank you all for joining. Thank you for sharing your knowledge with us. Do have a wonderful day, everyone. Bye.